All right, so I'm going to begin this video the same way that I did the other day or in our last video where we have a warm-up question. So I'll go ahead and put this warm-up question on the screen here. You can pause the video and you can try it, and then I will explain it as well. So here's our warm-up. Last video we were talking about essentially conjugates of imaginary numbers. So what I'd like us to try here is to subtract these two fractions. Okay, so the two fractions I want us to subtract are 3 minus 5i divided by 4 minus 3i. And we're going to subtract this minus 4 over 75. Okay, so again, pause the video right now and see what you can do here, and then I'll go over it. All right, so hopefully you paused the video and tried this. So the first thing that I would want us to do on this problem, remember we mentioned this the other day, this is a really hard problem to do as is right now because we would have to find a common denominator, and one of these denominators is imaginary and the other one is a real number, and so that's tough. So what I'm going to do first is I'm going to work with this first fraction to rationalize its denominator, and then once I've rationalized this denominator, then I can think about that second fraction. So what I've written right now is incorrect because, remember, in order to rationalize, we don't want to multiply by the same thing that we have on the bottom. We want to multiply by its conjugate. So this really needs to be a plus sign right here. And once I get this plus sign, then I can start foiling and I can see what I get when I simplify it a little bit and combine like terms. So let's start up on the top. So 3 times 4 is 12. 3 times 3i is a plus 9i. Then I have a minus 20i, negative 5i times 4. And then negative 5i times positive 3i is a minus 15i squared. Okay. On the bottom, remember two conjugates. When I multiply them, the middle terms cancel out. So this is going to be 16. Middle terms cancel out. And then negative 3i times positive 3i is a minus 9i squared. Okay. All right. Anytime you have an I squared, that's a negative 1. So let's think about this. This would be negative 15 times negative 1, which becomes a plus 15. And then right here, negative 9 times negative 1 is a plus 9. So we're almost done rationalizing here. So 12 plus 15 is 27. Negative 9i minus 20i is a negative 11i. Okay, and then 16 plus 9 is 25. All right, so we've got that. Now let's go ahead and let's bring this back into place. This is going to be minus 4 over 75. Now this is a little bit nicer for us to look at because we've got two denominators that are both real numbers, okay? And we can see here that the common denominator between 25 and 75 would be 75. Well, in order to get that, I'm going to have to take this first fraction and multiply the top and the bottom by 3. So let's go ahead and try that. I'm going to distribute this 3 here. I can put all of this on the same fraction now, because they have common denominators between both fractions. And from here, we just got to make sure we get our multiplication right. 27 times 3 is 81. Negative 11i times 3 is negative 33i. And then I have this minus 4 hanging out at the end right here from the 4 over 75. And my very last step here would be to combine like terms. 81 minus 4 is 77 minus 33i, all divided by 75. So that's the final answer. When I subtract these two fractions, it is a good assessment type question there for us to look at in terms of subtracting two fractions, which involves us rationalizing the denominator of the one that has imaginary numbers. Okay, so this video today is really going to serve as a review and using some strategies that we've learned earlier this year to solve equations. The only thing that's different is that some of the equations that we solved in this video might have some imaginary answers. Fortunately for us, there is no difference in terms of the solving strategy when the answer is imaginary as opposed to when it's a real number. So that's why I'm saying this is really just a review, because there's not going to be any sort of strategy here that you see that we haven't already talked about. But we'll just be reviewing a little bit of maybe what you see in terms of what you want to use to solve an equation. So let's say, I'm just going to jump right in here. Let's say that we had an equation that looks like this, and I told you to solve it. Let's say that we had 8x squared minus 8x plus 24 is equal to 0. Okay? All right. So earlier in the year, we've talked about when you have a quadratic equation, and this is a quadratic because the highest power that we see here is squared. There are a few different strategies you can try. You can try factoring. It's always the easiest way if you can do it. You can try completing the square. There are certain times where completing the square is the easiest strategy. And then last but not least, if completing the square is difficult, you can try the quadratic formula. I always encourage you to try it in these three steps or in this order because this is the order, in my opinion, that is the easiest. If it's easiest to factor, if it can be factored, factor. If it's easy to complete the square, complete the square. And if it's hard to complete the square, then you can try the quadratic formula. So let's start out with this problem. So if I was going to try to factor this, I would take the invisible number at the front, which is a 1, and multiply it by this number at the end, which is a 24. So 1 times 24 is 24. So what I would be looking for factors of here are, or what I'd be looking for here are two numbers that multiply to give me 24, but add together to give me this number in the middle, which is negative 8. So let's think about some factors of 24, and we'll list them off to the side. 1 and 24. Now, in this case, both of my numbers would have to be negative because they have to multiply to give me a negative, to give me a positive, but they have to add together to give me a negative. Okay, so that would be negative 1 and negative 24. Well, that doesn't work. Negative 2 and negative 12. That doesn't give me negative 8. Negative 3 and negative 8. That doesn't give me negative 8. Negative 4 and negative 6 is a little bit closer, but that also doesn't give me negative 8. And then I don't have any other options. So what that means is factoring is not a good option here. Okay, it's off the board. So let's think next about completing the square. So a couple of things for completing the square. In order to complete the square, a has to equal 1. That's a definite across the board. We're good to go on that. A is equal to 1. The number at the front is a 1. And also, the strategy for completing the square involves us taking the number in the middle, cutting it in half, and squaring it. Okay? And in this case, the number in the middle, what we'll notice is it's even. Okay, so in order to complete the square, you can complete the square all the time, but in order to do it, the easiest way for it to happen is if a is equal to 1 and b is even. And when I say a, b, c, all that stuff, I'm thinking about this. Ax squared plus bx plus c is equal to 0. So a has to be 1. That's good. And the number in the middle, you can still do it if it's not even, but if it is even, it's pretty easy. And in this case, the number is a negative 8. So I'm thinking completing the square is probably going to be my best bet on this problem. So let's try. Let's see if you guys remember the strategy of completing the square here. So let's say that I had this number at the front is a 1. That's good. So what I'm going to do here is I'm going to start by moving this constant to the other side of the equation. Okay. So I'm going to add or subtract that 24 over to the other side. I'm going to leave myself a little bit of space, and in that space, I'm going to put a plus blank. And in that space, that's where I'm going to complete the square. Okay. All right. So we got our number in the middle. What do we do with it? Well, we take the number in the middle, we chop it in half, and then we square it. Okay. So negative 8 divided by 2 is negative 4, and negative 4 squared is 16. So what I'm going to do here is I'm going to add a 16 in this blank on both sides of the equation. Whatever I do to one side of the equation, I got to do the exact same thing on the other side. All right, so negative 24 plus 16. Let's clean up the left or the right side. That's a negative 8. Okay, and on the left side, I can rewrite this. The whole point of completing the square is that you can rewrite the part you completed the square with as a quantity squared. And in this case, this would be x minus, remember the pattern is, we take this term in the middle and we chop it in half. So my negative 8 cut in half is a 4. Okay, and I often have students say, well, what in the world did you just do, Mr. Griffith? How did this become this? And what happened to the plus 16? All right, well, let me just make a note for you here. When I do x minus 4 times x minus 4, or when I do x minus 4 squared, that is x minus 4 times x minus 4. And if I FOIL this out, x times x is x squared, x times negative 4 is negative 4x, negative 4 times x is negative 4x, and negative 4 times negative 4 is plus 16. Negative 4x minus 4x is negative 8x plus 16. So look, I didn't do anything because this is the same thing as this. I just rewrote it in a different form, and that form is x minus 4 squared. Okay, so when we go from this step right here to this step right here, we're just writing it in its factored form. Okay, and all I have to do is just take this middle term and chop it in half. Okay, from here we can take the square root of both sides. That's how we get rid of something that's squared. That's again the whole point of completing the square, so that we can take the square root of both sides. So the square root of x minus 4 squared is x minus 4. The square root of negative 8, this breaks down into the square root of 4 times the square root of 2 times the square root of negative 1. Okay, so the square root of 4 is 2, the square root of negative 1 is I, and then I'm going to leave that square root of 2 right there. But remember, if it's an imaginary answer, or sorry, if we're taking a square root, we must put a plus or minus. And you'll notice our answer is imaginary here. So the last thing that I would do, just like always, is add that 4 to both sides. And my final answer is 4 plus or minus 2i times the square root of 2. Okay. Now, what I want you guys to notice here is our answers are imaginary. I want us to just do a little bit of, this is a side note, but look at this equation again. X squared minus 8x plus 24 equals 0. So if you think about this, and again, this is not necessarily pertinent for what we're doing here, but I'm going to note it anyways. When I set an equation equal to 0 and I solve for x, what I'm doing actually is I'm finding the x-intercepts. Okay. What you'll notice here on this one is that our x-intercepts are imaginary. So what I want us to think about is, if this was f of x, essentially what we just did is we solved f of x equals 0. What I want us to think about is, would f of x cross the x-axis? And your initial answer should definitely be no, because the x-intercepts that we got were imaginary. But I want us to just think about it for a second. This is going back to something we talked about in the first semester, but let's think about this quadratic here. If I wanted to find the vertex of this quadratic, here's what I would do. A lot of you missed this on the final. This problem stumped you. I gave you a quadratic and just said, hey, find the vertex. And lots of people were like, oh, I don't know what to do. So anyways, the vertex for this quadratic, what we do is we do negative b over 2a. So that would be, in this case, negative 8. So 8 divided by 2 times a, which is 1. So that would be 4. Okay. So the x value for the vertex is 4. The way we would find the y value is we would just plug in 4 for x. So that would be 4 squared minus 8 times 4 plus 24. So this would be 16 minus 32 plus 24. So negative 16 plus 24 is 8. So therefore, the vertex of this graph is 4, 8. So let's just sketch this real quick. 4, 8. That's over 4 and up 8. So it would be like right here, somewhere thereabouts. And then this quadratic has a positive number at the front, positive 1, which means it opens up. So check this out. This graph is not crossing the x-axis ever. Okay, and because it's never going to cross the x-axis, when we solve for the x-intercepts, we get imaginary numbers. Okay, so if you ever get imaginary numbers, that means if you were to graph what you see on the left side of the function when it's equal to 0, whatever that thing is, and it should not cross the x-axis at all. If it does cross the x-axis when you graph it, then it means you shouldn't get imaginary x-intercepts. Okay, so again, this part right here that I'm doing, this is not necessary for the problem. You do not have to do this. However, I'm just kind of relating back to graphing and solving, and want to make sure that we keep those things in mind as we go. All right. So there is me using completing the square to help solve an equation. Again, we're not necessarily going to get imaginary answers on all of these, but if we do get something where there's a negative when we take the square root, then we know that our final answer is imaginary. Okay, let's look at another problem here. And we'll see what we've got. Got a couple of days of notes from last year, so I'm just kind of glancing through them here. Let's say that we wanted to solve this. So let's say that we had x squared plus 7x. Actually, no, let's go with, sorry. Let's flip this. Let's try 5x squared minus 2x, and let's do plus 4 is equal to 0. Okay. All right. So if we were going through our processes of seeing if we could maybe solve this thing using just all of our strategies, let's try once again factoring, completing the square, and quadratic formula. I'll write these down here. If I was going to factor this one, I would be doing 5 times 4, or looking for factors of 5 times 4, which is 20, that add up to negative 2. Okay. Well, if I think about 20, once again, both these numbers would have to be negative because I got to multiply to a positive number and add to a negative. I would do negative 1 and negative 20. That doesn't work. Negative 2 and negative 10. That doesn't work. And negative 4 and negative 5. That doesn't work. And I think those are my only options. So once again, factoring is off the board here. Okay. Now, when it comes to completing the square, right off the bat, I'm going to eliminate completing the square because in this case, a does not equal 1. And it's not that we couldn't complete the square here, but if we wanted to complete the square, what we would have to do is we'd have to start by dividing everything by 5. And if I divided everything by 5, I would have fractions all over the place. And so that looks really ugly. So completing the square, probably not my best option here on this one either. Okay, so if completing the square doesn't work, if factoring doesn't work, that leads us to the quadratic formula. So let's see, first of all, does anybody remember the quadratic formula? So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay. All right, so all the quadratic formula is plug and chug. But you do need to identify what's A, B, and C first. So in this case, A is 5, B is negative 2, and C is 4. So let's go ahead and plug those in, and then let's see what we get with our quadratic formula. So let's try it. All right, quadratic formula says negative negative 2, so 2 plus or minus the square root of B squared, so that would be 4 minus 4 times 5, so 4 times A times C, all divided by 2 times 5, 2a. All right, let's do some math. So we've got 2 plus or minus square root of 4 minus, because I'm going to stay negative because I got just minus and then a bunch of positives. Let's see, 4 times 5 is 20, times 4 is 80. All divided by 2 times 5 is 10. Okay, 4 minus 80 is negative 76. All right, let's make that a little bit more obvious there. Negative 76, and check this out. I got a negative underneath the radical, which means I am going to get an imaginary answer here. All right, if you leave it just like this, though, you are not going to get full credit. Let's simplify this. The square root of 76, negative 76. This breaks down into square root of 19 times the square root of 4 times the square root of negative 1. Okay, I know that 20 times 4 is 80, so 19 times 4 has to be 76, and then I've got that negative 1, which is indicating that my answer is going to be imaginary here. So the square root of 4 is 2. So let's see, let's write this here. It's going to be 2 plus or minus. Square root of 4 is 2. Square root of negative 1 is I. Can't do anything with the square root of 19, all divided by 10. And then last but not least, what you'll notice here is 2, 2, and 10 are all even numbers, meaning I can divide everything I see here by 2. So I can divide 2, 2, and 2. This is going to be 1, 1, and 5. So my final answer to this problem is 1 plus or minus I times the square root of 19, all divided by 5. Okay, so once again, I get imaginary answers here. So if you think about it, whenever I graph the left side of this equation that's equal to 0, I should not ever see that graph cross the x-axis because in this case, I got imaginary answers when I'm done. All right, let's finish out with this. I just want us to practice a little bit. I do not know if this answer is going to have real number or imaginary. I'm just doing this one off the top of my head here, but This is just a straight up review question. Let's solve with completing the square and the quadratic formula. Okay, and again, if you want to try this at your desk, you can. And then you can pause it and try it, and then we can go back to it. You can see my answer. But let's look at this formula. Let's start at this equation. Let's try x squared minus 5x plus 1 equals 0. I'm just going to tell you right off the bat here, factoring is off the board. But let's try completing the square, and then let's try quadratic formula. And if I'm going to use the same if I'm going to solve the same equation two separate ways, I should get the same answer both times. So let's give it a shot. So with completing the square, this is going to be a little bit trickier on this one. I do have a 1 at the front, but you'll notice here I'm going to begin by subtracting the 1 over to the other side. What you'll notice here is that that middle term is odd. So I can still do this, but I'm going to have to use fractions in order to make this happen. So negative 5 cut in half and squared. Negative 5 squared is 25. 2 squared is 4. So I'm going to add 25 over 4 to both sides of the equation. All right, let's clean this up a little bit. So on the left side of the equation, the whole point of completing the square, as I mentioned earlier, so that I can write this as a quantity squared. Shortcut here is just take this middle term, cut it in half. So this is going to be minus 5 halves. Okay, and that's going to be equal to, and on the other side, negative 1 plus 25 over 4. Well, that's the same thing as negative 4 over 4 plus 25 over 4. Okay, and so negative 4 plus 25 is 21 over 4. And check this out. What this means is on this problem, I am not going to get an imaginary answer because as I do this, or as I try this, the number on the right side, when I take the square root, that number on the right side is positive, meaning it's not going to be imaginary. Okay, and that's okay. We're going to use all the same strategies. It's just we're not going to have an imaginary answer when we're finished. So this will be x minus 5 halves. The square root of 21, I can't do anything with that. So this is going to be plus or minus square root of 21. But on the bottom, the square root of 4 is 2. And last but not least, I can add 5 halves to both sides. I already see common denominators here, so when I'm finished, it's going to be 5 plus or minus the square root of 21, all divided by 2. Okay, so here's what I get when I solve this by completing the square. Let's double check with the quadratic formula. Do I get the same exact answer? Okay, well, let's try it. Here's my equation. Okay, we already noted, hey, we can't factor this one. We just solved it with completing the square. It was a little tricky because I had to use a fraction. Let's try quadratic formula. Let's see what we get. So x equals negative b. So this is, let's write these down here. A is 1. B is negative 5. C is 1. Okay, this would be negative 5. So 5 plus or minus the square root of 25 minus 4 times A, which is 1, times C, which is 1, all divided by 2 times 1. This would be 5 plus or minus the square root of 25 minus 4 times 1 times 1 is 4, all divided by 2. And 25 minus 4 is 21. Okay. And so, as I expected, solving this by completing the square or the quadratic formula yields the same results. Okay. And just note that on this one, my result is a real number instead of an imaginary number, but that doesn't change anything. We still use the exact same strategy to get this answer just like we did in these first couple examples that we tried. Okay, I'm going to include a little bit of practice in the OneNote here on a separate slide, so check that out. That's all I got for this video. Tomorrow in class, we'll be working on some more practice with solving equations. And so that kind of wraps up the first part of this unit, and we'll jump into doing some graphing in our next video. Bye, all.